this for the slides. Oh, there we go. Perfect. Hi, I'm Jim Mlodgenski. Talk about Postgres CDC. Right? What is CDC? It's change data capture. Why do you care? Because right now, data is a tsunami, as we've heard throughout the whole conference. Data is growing and growing and growing, and we like that. But Postgres is the center of the universe, but it doesn't work for everything. You need to be able to integrate stuff with Postgres from other places, and CDC lets you do that sort of thing. But we need to be able to interact with those other data stores because you have data warehouses. You have big data. You might be putting things into Greenplum or Redshift or Hadoop. You might have some NoSQL laying around, whether it's Cassandra or MongoDB. Or you might be doing full text search with Elasticsearch or other types of things that you got to integrate Postgres in with these other data stores, right? Or some memory cache. You have your high-speed website. You need to be able to have everything returned out of memory quickly for low latency stuff. But you need everything, all your data stored in Postgres. How do you integrate all this stuff? That's what CDC does. And it lets you know what to sync to those other data stores along the way. Traditionally, you do it through polling. Right? So you have some sort of SQL query, you do select, and you might have some last updated date in order to find everything that's changed in the last 5 minutes or so, right? Or you go down the triggers route, right? Every time you make a change to your database, you have some sort of trigger, elaborate trigger that goes ahead and gets all those changes, and then you come around and poll it separately, right, in order to be able to go make those changes. Or we could get a little bit more elaborate with triggers with foreign data wrappers, because Postgres could talk to all these other data stores, which is really cool, right? So you could write a trigger that when every time you make a change on your table, it'll go delete the cache entry out of your Redis cache or something else. Downside is of all those triggers is that it's not very efficient, right? So slide got a little cool there, right? I'll short it up. But they're not very efficient. There's a trigger overhead. Every time you do a little change to something, you have to pay that trigger tax. That's where logical replication comes in. You have this really cool thing, this logical replication stream, that every time you make a change, you could actually see it coming through. So you have the PG receive logical with the test decoding plugin. You could actually see everything that's coming through. Not really that useful in this thing for the command line. Where it really gets cool is it now works with all the Postgres drivers. Like it works with the JDBC driver, the Python driver. So you can write a little bit of Java code in order to be able to see all the changes coming out of your database in near real time and be able to go integrate that with all your caches. So this way you could update your memory caches, you could populate your full text searches, and then be able to do things in near real time without paying your trigger tax, and it makes it really, really flexible. Done.